over to you, Chris and Peter. Thank you so much for joining us. And yeah, we'd love to learn from you both.
Well, thank you for the introduction, and I'm sorry I cannot be in London in person, but for obvious reasons, but I look forward hopefully to an in-person event soon. So I am sure that I can speak on behalf of Chris as well to welcome everybody to this user group presentation titled Demystifying Power BI Datasets. So Chris and I have had a big discussion about this, and we shared a number of common findings that there were all of these terms related to data sets, and yet we're finding, customers or students are confounded by features, capabilities, frameworks, and terms that are used in Power BI. And so after all, Power BI is a service that's undergone enormous change and growth over the past 5 years. So in our experience, we've found that it's common to be confused. And we're experts. And I think to a degree, Chris and I even got confused and had some very healthy debates as we put this content together. So it has inspired us to produce this presentation that really is like a glossary of terms in relation to Power BI datasets. So we're going to use this presentation to walk through a subset of them. We've discovered that 50 just doesn't fit into a normal time slot, but we'll go through the important ones, and we'll think that there's absolutely no doubt that you, as beginners or even as well-advanced practitioners, you're going to learn something unexpected and new. So very briefly, myself, Melbourne, Australia, Peter Myers, Data Platform MVP, specializing in Microsoft BI, and of course, these days that means Power BI.
And my name is Chris Webb. I work on the Power BI Customer Advisory team at Microsoft. Peter, are you sharing slides?
I thought I was.
You're not.
I'm out of practice too, so I'm not, and you pick me up right now. So what you've just missed is this amazing introduction. Let's just begin from the beginning because it's being recorded, right? So where we began was here. Are you confused, confounded by all of these terms in relation to Power BI datasets? Hello, my name is Peter Myers, and Chris is Chris Webb. We'd like to take this opportunity to ask who you are, and the way that we do that, very briefly, is I'm sharing a link in the chat window, and that link allows you to click and open up a very simple survey. And what that's going to present back to us is a real-time Power BI dashboard that is going to show us a little bit about who you are as a group. So please, I invite you, take a moment to submit details about who you are. All right, seeing that we've got a good number in the of people in the Teams meeting, let's see that number get to at least 50, hey? And an assessment here, I'll take a look at the role there. So the top polling role is the BI developer, followed by the business analyst and the data architect. So that really is very much our target audience. When we're talking data sets, it's those data modelers. Chris, any comment on the Power BI experience?
What, this wonderful live updating report looks amazing to me. What is this product we're using?
Well, it's a dashboard, and it's a real-time dashboard. So we might have the opportunity to talk about real-time data sets tonight. But more specifically, we look at the visual for Power BI experience. We've got this, what have we got? We've got everywhere from 0 through to 10. So welcome to people that are beginners, perhaps have heard about Power BI, but know nothing much more about it. We'll certainly get you started on your journey with Power BI. By the look of it, we've got a couple of ninjas and a Jedi in there as well. Chris, which one are you?
I would say I'm my own person. I'm particularly pleased to see that we've got somebody in the 95 to 99 age bracket as well.
Yes, so a centenarian almost by the look of it. Okay, well, we've got a number of 86. I'm very impressed. That's a really good number. And I've got to say, having, for many years delivered community events and conference events, it really is such a mind shift not to see your audience in front of you. So it's really a good gauge for me about, okay, who's actually here and listening and interested. What we'll do is we'll just click through and take a look at the underlying report because there was that additional question about what is the important topic for you. And this will help Chris and I perhaps prioritize certain terms in the glossary. Chris, any comments about this?
People always want to hear about optimization, don't they? But we will not be talking about optimization tonight. This is all about, it's not tonight, it's the afternoon, it's the morning. I'm getting confused. It's your tonight. Yeah, we will not be talking about optimization. We will be talking about fundamentals. Peter loves real-time analytics, so I'll let him speak about that as well today.
So actually, we will talk about optimization. So I'm happy to substitute real-time analytics out. So let's see if we can fit optimization in, because if that's the demand topic, I reckon we can do it. So that pretty much sets the agenda for us. I reckon we're on track. So thanks very much for participating in the survey. Let's switch back to the presentation and we can get started. So the way that we've organized this glossary of terms is into these groupings. And so what better place to begin than with the fundamentals? Chris.
So let's talk about datasets. I think datasets are the most important thing in the whole of Power BI, because every time you view a report or a dashboard inside Power BI, that data has to come from, or at least via, a dataset. So datasets are a must-have. You cannot do anything useful in Power BI without a dataset. Datasets live in workspaces, but you can access the data in a dataset from outside a workspace, across a different workspace, for example.
Right, so let's see an example. So here we've got workspace A. It has a single data set and a couple of reports and a dashboard, yet within the same tenant, we see workspace B that has a different data set and a couple of reports. But notice here that report B1 actually connects to dataset A1. This is perfectly legitimate. So as Chris has mentioned, data sets can be accessed across workspaces, granted that the correct permissions are in place. This furry character, paginated report bearer, is saying, hey, hold on a minute, Chris, but what about paginated reports?
Peter, do the voice, please.
Oh, okay, sorry. But Chris, what about paginated reports?
That's better. That's better. Now I'm happy. All right, I have to make Peter do the voice because my role in this presentation, or one of my roles in this presentation, is to be the fall guy. And this is a great example of where the guy from Microsoft has to apologize for what Microsoft has done. We do have a nasty habit of reusing terminology. And when we talk about datasets in this presentation, we are talking about Power BI datasets. Of course, now in Power BI, we have paginated reports, which are old SQL Server reporting services reports in the cloud. And in SQL Server reporting services, we also had the concept of datasets. So we have paginated report datasets inside Power BI, which are not the same thing as Power BI datasets. And we will not talk about paginated report datasets anymore after this.
Yeah, so just to complete that and then disconnect from this topic, is that a data set in a paginated report is a command to retrieve data. Like it's a select statement or a stored procedure execution. And just to make things a little more confusing is that if you add a data source to a paginated report, you can connect to a data set. And then you can create a paginated data set based on that data source. So let's not confuse you any further. Moving forward, everything we talk about is now the Power BI artifact of a data set. Now, let me speak briefly about the Datasets Hub, because this is sort of a recent addition to the Power BI service, allowing you with ease and convenience to come in, select that hub in your navigation pane, and to gain quick visibility and discoverability across the datasets that you have permission to work with.
So we often hear people talk about data models in Power BI as well, don't we? What's the difference between a data set and a data model, really? Well, what I would say is that a data model is an abstract term. A data set is a real thing. You can go to the Power BI service and you can see a data set listed there. Whereas a data model is, like I said, a bit more abstract. get people talking about models, data models, semantic models. A data model is just something that is a queryable resource that can be used by Power BI, that can be queried in one of Power BI's query languages, either DAX or MDX.
So sometimes you'll see it in documentation called a semantic model, or in the context of a data discussion, it's simply called a model. Now, leads us to the next term, and I feel very strongly about this one because it is the rhythm and dance that Power BI does with your data, from visualization, is done through analytic querying. And if we describe that an analytic query is the way that a model is queried and that it has three distinct phases of filter, group, and summarize, let's explain how with an example. So here I can see a set of data comprising all the company's sales orders, of which there are thousands, and I need to answer a simple question, like what were quarterly sales in 2021? Now, to answer that question, the data needs to be filtered, then grouped, and then summarized. And while you may not be aware the analytic query is actually working in the background, the way that you configure a visual in Power BI achieves this filtering, grouping, and summarization for you. For example, the way that Power BI would do it is that we might have a filter on the page with a slicer. So there's where the filter is coming from. We could add a column chart visual where we group by the quarters on the axis. There's your grouping. And then the heights of those columns is the summarization of sales amounts. So when you think about it, every visual is doing an analytic query to filter, group, summarize.
So we've talked about models as an abstract term. We should also go into a little bit more detail about the types of models that are available. In Power BI, what we work with mostly are what are called tabular models. So if a model is something that can be queried, a tabular model is something that can be queried that arranges its data in the form of tables, tables that have columns, tables that are joined to each other through relationships, tables that have hierarchies, tables that have calculations on. In the world of Power BI, we are always dealing with tabular models. All of the data sets, a Power BI dataset is a type of tabular model.
So I think now is a good time to introduce, the primary tool that we use as a business analyst or BI developer with Power BI, and it is Power BI Desktop. And so this tool is versatile because it actually does two distinctly different things for you. It allows you to create a data model, and it also allows you to define a report that is based on a data model. Now, with our focus on the tabular model then, why is it a tabular model? Well, these tables are what are the foundation of your model. And most commonly, the tables are sourced from an external data store, and Power Query is the technology that allows you to connect and prepare and transform data. Therefore, you can have a Power Query data source, and it can have one or more queries. And when loaded to the model, those queries become tables. All right, there is another approach to add a table, and that is that using DAX as a formula language, you can create a table. However, it cannot connect to external data. The best that it can do is generate series of data or transform existing data that's already been loaded to the model. So there's the foundation of your tabular model. Yep, the table themselves, they're comprised of columns, which can also be calculations in DAX. And where you have one or more tables, you'll have relationships allowing filter propagation to take place, and more on that in just a moment. To improve usability, you might optionally add hierarchies that comprise levels. Those levels are simply an ordered sequence of columns from the same table. And then we've talked about filter, group, summarize. Well, the summarize part can come in that using DAX, you can define measures that determine how to summarize model data. So for anybody working with Power BI, you need to be very familiar with the tabular model and all of these objects that work together to produce that queryable resource that the visuals need.
So I said that all of our models in Power BI are tabular models, but what should we do with our tables? We can't just have any old tables inside Power BI. Things wouldn't work well. When we're thinking about how we build our tables, what data should be in each table, how those tables should be linked together, there is a specific way of modeling data that Power BI likes, and that's called a star schema, a dimensional model. This is not a Power BI specific term. This is something that has been around in the BI industry for a long, long time, since I was young, maybe even since Peter was young. And it's well known from the works of people like Ralph Kimball. Peter, have you got that Lawrence Core book you were showing me the other day? There are still, people writing books and teaching courses about star schemas and dimensional models. We don't really have enough time to go into dimensional modeling in detail today, but the key thing about a dimensional model and a star schema is that you have to classify the tables in your model as either dimension tables or fact tables.
Right. So while it is a mature modeling approach used by enterprise data warehouse developers, it applies even to some of the smallest, simplest models that a business analyst might create in Power BI Desktop. So why is it called a star schema? It's because you have this fact table that accumulates your transactional history, your events, your observations that you want to analyze. And then the points of that star are your dimension tables that represent your business entities or your things. So back to the analytic query. Those dimension tables are for filtering and grouping, and the fact tables are for summarizing. All right. So the way that we're thinking it as we use Power Query to define the tables that are loaded to the model, we're thinking about what role does it play. Now, as Chris has said, this is an important topic, but we can't spend the whole day talking about it. We'd love to. But the important concepts we'd like you to be aware of, especially for your beginners, that these terms might be unfamiliar, knowing what a dimension and fact table is, knowing what granularity means and what dimensionality means, surrogate key and measure, I would say are very important concepts to know. I've included a link here that I will come back to at the end of the presentation, which is a great article from the Power BI docs on guidance. And for those that are new to Star Schema, this might be the gentlest and easiest way to become familiar with these concepts. I'll talk about fields because fields doesn't really fit into a tabular model. What we see is that fields are specific types of objects that can be used to configure your Power BI visuals. So specifically, there are three types. You've got columns, you've got levels of hierarchies and measures. While these are different objects in a tabular model, collectively, they're known as fields, meaning that they can be used to configure a visual.
Now, we've talked about data sets, and one question that I, as a Microsoft person, get asked all the time is, what about data flows? What is the difference between a data set and a data flow? So I've already said that a data set is a must-have. Every time you do anything serious inside Power BI, you have to have a data set. A data set is the source of data for your report. What's the difference between a data set and a data flow? A data flow is just a data source. When you build your data set, you specify the sources of data for that data set. And those sources could be an Excel file, a CSV file. It could be a relational database like SQL Server. But a data flow is something you can build inside your Power BI, and it's a kind of intermediate store of data. It's not something you can build a report on directly, but it is something that a data set can get data from. So Peter, I think you've got some slides showing this.
Yeah, well, let's consider an example. So in our workspace, we've got a data flow and we've got a report, and many people think the report could just query the data flow, but as Chris has just mentioned, they're wrong. So what you do need is Power BI Desktop, and Power BI Desktop will allow you to connect to that data flow and import the data into your data model. So it's just another source of data. When you've completed your model development in Power BI Desktop, you can then publish that back to the service, whereupon that model is now the data set in the service. Now, there is a relationship there between the data flow and data set. You might configure a recurring schedule that refreshes the data daily, and then we can see the report can query and send those analytic queries to the data set. All right, so good examples of a data flow, by the way, are master data, that data that is reused across lots of models like product or employees. So if you want a single version of the truth, you might publish, the golden record of your master data as data flows, and then encourage their reuse across multiple models. That gets the fundamentals out of the way. So we're going to progress to the next group of terms, progressively getting much more interesting and complex. Now to introduce some terms in relation to hosting.
So I've talked about data sets, and we've talked about this abstract concept of models. Where do models live? You know, what kind of models can you have? So the first thing we'd want to talk about is internal hosted models. We can have models that live inside Power BI.
Right, that's a pretty straightforward concept, right? So when you publish that model developed in Power BI Desktop and you publish it to a workspace in Power BI, that's considered to be an internal hosted model. It's hosted in the Power BI service. So literally, you'll see that model is there in the capacity. It then begs the question, well, then if we have internal hosted models, what's an external hosted model? Well, it means that the model resides outside. And there are two options that Microsoft provide for you. That is Azure Analysis Services for tabular models, and the oldie but goodie, and this is where Chris and I go back many years, is SQL Server Analysis Services that supports two types of modeling, not just tabular, but the older and not necessarily redundant multidimensional. So Power BI will allow reports to connect to external hosted models. And when it does so, it's referred to as a live connection. So let's explain. Here in the Power BI service, I've got dataset A, and we can see here that it connects through to an Azure Analysis Services model. That's one scenario. But consider a second scenario where dataset B supports connectivity through to SQL Server Analysis Services. In this case, it looks to be a tabular model, or a multidimensional, excuse me. And in this case, be aware that you would require the on-premises data gateway to support secure communication to and from that on-prem instance of SQL Server.
This leads us on to the topic of live connections. Live connections, or the term live connection, is again something that people get really confused about, and they tend to use it instead of direct query. We'll talk about direct query a little bit later, but a live connection is simply a connection to a model. You know, you'll see it inside desktop, and we'll cover that a little bit later. But it is just simply the fact that you know, you're connecting from your Power BI report back to a data set, or a data set that points to an external hosted model.
Right, so it's sort of, in my thinking, there's an overloading because live connection means two distinctly different things, as we've begun to describe there. So imagine that we've got here in Power BI, we're authoring a report. So we already have this data set. So we just go and open Power BI Desktop, and we can just live connect to it. We don't need to create a whole model because that model already exists and it's published to the service. So while authoring the report, we call that live connection. And then when you've completed the development of the report and you publish it, well, Power BI Desktop sort of disappears from there, and we see that the report simply queries that internal hosted model. So it's a report authoring concept that Power BI Desktop on your desktop is live connecting to your cloud hosted model. Now, the second time we use live connection is that it's a dataset connection to an external hosted model. As we've already described, you can have this dataset that points or connects through to an external hosted model. Therefore, we refer to this as a live connection dataset, that reports that query the dataset are actually being redirected to query the external hosted model. All right, brings us to the bigger topic where things start to get very interesting, and that's the topic of model frameworks.
So we've talked about models. We talked about models that are tabular, i.e. we've got tables in them. Where does the data actually live? We've got three options, two fundamental ones, one which is a combination of both. And they are import mode, direct query mode, and dual mode. We'll leave dual for a little bit. Let's talk about import mode and direct query mode first.
Well, let's firstly just point out here in the diagram, what we're referring to is that tables that are loaded from Power Query have a property that determines their storage mode. So this will not apply to DAX calculator tables. So, as Chris had mentioned, there are three different storage modes, the third being both at the same time. So what import means is that it literally loads the data and stores it inside the model. The more volumes of data you have, the larger the storage size for your model. Whereas direct query is a pass-through mode. The data stays in the data source and it can be queried via Power BI. Dual, as we'll talk about later, can do either depending on circumstance. So for now, let's describe what happens when every table in the data model is set to be import storage mode, because it is the most common, because it is in fact the default that you'll have in Power BI Desktop. So what we define here as a term, being an import model, is one where every table is using import storage mode. What that means then is that you can import data from any data source connection. And as you see there, that star grows, representing that as more and more data is imported, the size of the model grows. So what happens is that when in Power BI Desktop you connect to a data source type, like in this case, SQL Server, you will see that there is a data connectivity mode and it will default to import. Yet if the data source supports it, or Power BI supports it, that you could switch to Direct Query, and we'll talk about Direct Query in just a moment. Now, the benefits of using import are massive, all right? It's the reason why it's the default, because there is no restriction on the data source type. It enables integration whereby you can import from multiple sources into the one model. It supports the entire DAX and Power Query functionality. It allows you to enhance the model with calculated tables using DAX, and it delivers the best query performance. And the reason for this is that as data is loaded into the model, the analysis services engine will compress and optimize and index that data for high performance analytic queries. Remember the filter group summarize. The data is already optimized for those types of query operations. Yet when there are benefits, there are also limitations.
And if you're importing data into Power BI, well, that data has to be stored inside the Power BI service or in Power BI Desktop in memory on your PC. That means that there are going to be restrictions on how much data you can load in. Now, these vary depending on the environment, but in the Power BI service, it's generally 1 GB. If you're using Premium, you can increase that a lot. But generally speaking, most people will be working with 1 GB limits. The second thing to bear in mind is that if you're copying your data into Power BI and the original source data changes, well, you've got to reload the data to make sure you've got the latest data inside your Power BI dataset. And then finally, the thing you've got to bear in mind is that when you're copying that data, doing a data refresh, that reloads by default all the data. Now, there are ways around this. There are ways that you can just refresh some of the data, not all, but by default, it's going to load everything.
So these limitations can be addressed. If we have massive volumes of data, does that mean we can't use Power BI? No, of course not. And that's where the Direct Query storage mode comes in. So the next term we'll talk about is a Direct Query model, whereby every table in the model has a storage mode of Direct Query. Remember, it's using a pass-through. So we can see in this instance, while we've still got our well-designed model, that when a report will query that data set, we will see that it will pass through to the underlying source, which in this case happens to be an Azure SQL database. Now, if you're using a connector like SQL Server Database, you're going to have to intentionally switch the connectivity mode to Direct Query. But when you do so, there are some enormous benefits. So it will enable reporting over massive sets of data. It could be a petabyte data warehouse, and Power BI can still visualize that data. There is no requirement for data refresh because it passes through to the underlying source. Therefore, it can deliver near real-time results. And as we'll discuss shortly, there's a very interesting new and still in preview capability that allows personalization or extension of a data set by using a Direct Query connection. Again, where there are benefits, there are also limitations.
But this sounds so enticing. This sounds so amazing. Why would I ever use import mode? Well, this is where the downsides of Direct Query mode come in. The first thing to understand about Direct Query mode is that you cannot use it with all data sources. Direct Query mode can only be used with data sources where Power BI can pass through that query, which therefore support some kind of query language, almost always SQL. You can't do Direct Query mode with an Excel file because there is no way of running a query against an Excel file. In terms of other limitations, you will find you can do some things in the Power Query editor to transform your data, but you can't do everything. Most importantly, though, the biggest limitation of Direct Query mode is that you can run into performance problems. And by performance problems, I mean that your report can be slow to render. Now, that's not necessarily the case. You could tune your data set, you could tune your data source, but it is certainly much, much easier to get good report performance with a Power BI import mode data set. The last thing maybe to mention is that if you're passing through queries to your backend data source, and your backend data source is an ERP system or some other system that's doing other work, the kind of BI queries that Power BI generates can be quite resource intensive, and that can cause problems for the people who are using your CRM system, your ERP system, or whatever's going on in the background.
Right. So in my opinion, while you've got this fantastic capability, it's one that you should at least have the courtesy to discuss with the database owner that has, so gratefully given you read access to their database, that if you're going to add this entirely new workload, and then, you create this beautiful report that becomes very popular, it's distributed throughout the organization, and all of a sudden that CRM system isn't able to do what it's trying to do because it's trying to also deliver these analytic queries. So we're not trying to put you off the topic, but would strongly suggest that it's a collaborative effort between you as the data modeler and the database owner to ensure that the database has sufficient resources and is tuned and optimized for that workflow. Now, the next term we'll introduce as we get more interesting is the concept of a source group. So by definition, it's a set of model tables that are related to a data source. And there are two types of source group. There's an import source group, and there are direct query source groups that relate to each direct query source that you might have in your model. Now, you may already be familiar with this term because it was previously referred to as data islands, but in more recent times, it's been relabeled as source group. So what might it mean? Here we see this import model, but what we could do is start to introduce some variety in the storage mode of our tables. We could have import storage mode tables and some direct query storage mode tables. And so now what we've got are two source groups. We have one source group that is storage for all of the import data, including calculated tables. And then for tables that belong to this Azure SQL connection, they belong to that source group. And it's quite possible, although probably not a great idea, but you could have multiple direct query connections here, and therefore there could be multiple source groups, each for the direct query sources. That leads us then to another definition. We have import model, direct query model, but where you have a blend of storage modes and therefore more than one source group, then we have what's known as a composite model. So probably best to switch to a model diagram at this point. And so what we can point out is that when you look at the model diagram, you can actually determine that the date and journal tables are using import storage mode. And I know that because there is no colored bar across the top. And yet the other three tables, scenario, scenario amount, and account, have this blue bar indicating that they're direct query storage mode, and by color, they belong to the same source group. So in fact, just by hovering your cursor over a table in the model diagram will confirm the storage mode for you. And there we see the direct query storage and specifics about the direct query data source.
So we talked about import models, we talked about direct query models, we talked about composite models. I've seen something in the bottom right-hand corner of Power BI Desktop that kind of tells me the mode that I'm in. But that doesn't really seem to kind of reflect what we've just been talking about. So let's try and understand what that message in the bottom right-hand corner of Power BI Desktop means. Because once again, it's my job as the person from Microsoft to apologize because it is a little bit misleading and needs a little bit of explaining. So go ahead, Peter, tell us what it means.
Well, you'll see three different things there, either live connection, direct query, or mixed, or sometimes you'll see nothing. Okay, now if you see live connection, we've already described this. It means that you're actually in report authoring mode. There is no data modeling going on. You're connecting to some live connection source. So therefore, it could be any model framework. It could be an import direct query composite model, and there could be multiple source groups. When you see nothing, which is the default, remember this import storage mode. So for whatever reason, Microsoft mean that if there's nothing in the bottom right corner, then your tables are all in import storage mode. Therefore, there's just the one source group. When you see direct query, this is where things get a little wonky. You could be a direct query or composite model because you could have multiple direct query source groups, but no import source group. All right, so all direct query mode is telling you is that all tables have direct query storage mode, but not necessarily are they querying the same data source. And then mixed as Power BI desktop mode means that you're definitely composite. There's definitely an import source group and one and possibly more direct query source groups. So I think we can leave this topic here. It's not terribly important. I'd say it's much more important to understand model frameworks. But just to provide a connect to the status that you might see in Power BI desktop, there's the logic behind what its modes mean. All right, so let's take a look at this diagram again. And Chris, maybe you can help us out here. Just a bit of a quiz, just by looking at the diagram. How many source groups do I have?
I hate tests like this where you put me on the spot. Well, source groups are kind of indicated by the colored bars at the top, aren't they, Peter? So I can see two different colors. There's the blue bars and then there's nothing there. So there must be two source groups.
Well done. So what's the model framework?
Okay, so one of the colors is no color at all. So that must mean that we've got import and we've got direct query. So that must be a composite model.
In the desktop mode?
Well, that must be mixed.
How many data sources?
Well, this is a trick question. How do I know how many data sources there are? There could be lots. There could be just one. I think you built this. Tell me.
Yeah, it is a trick question because you cannot answer this from the diagram. Well, not if it's in mixed mode. If there were only direct query connections, you could answer it because the colors would tell you. But the actual answer is one. And you might say, well, hold on a minute, that sounds odd. Why would you have a single data source and have some imported and some direct query? And this is, in fact, a real example from one of my customers, is that the import tables represent the journal transactions that hit their accounting system. And that's refreshed at 6 a.m. every morning. But they do write back to determine what their budgets and forecasts will be. So for scenarios like budget and forecast, and because they're doing write back, we use direct query storage mode. So when the write back is completed, we just go back to the Power BI report and refresh it, and we get an instant update showing the actuals against the recently written scenario data. All right, so a good example of a composite model that just happens to use a single data source, although that's probably not common. You'd probably find that your import data is coming from a variety of other sources. All right, let's move to a new definition then, local model. So we have local and remote, and this builds up a very interesting new capability. So the groundwork needs to be done by defining that a local model is one that is being developed or queried, and it's a relative term to describe a model with a direct query connection to a Power BI data set. So with a local model, it's local to you in Power BI desktop, or it's local to the Power BI service where the report is querying it. But what remote means is relatively, it's away from you. It's upstream from a local model. So I think the best way to describe these is not through pure terms and definitions, is actually to give you an example. And it allows us to introduce this new and in preview capability of direct query to Power BI data sets. So imagine this scenario that in the Power BI service, we have what's known as a core model, meaning it's the analytic source of truth. So in this case, it happens to be a direct query model that's connecting to an Azure Synapse Analytics data warehouse. So as a business analyst, and assuming that I have permission, I can open Power BI desktop and create a live connection to the data set. And in this live connection mode, I could author a beautiful report. Now, the story here is that my manager has asked me to produce a sales per capita report. And so what I recognize is that the core model doesn't have population. So what I'm going to do is edit the live connection, which creates a local direct query model for me. So it actually just copies the metadata of the core model into Power BI desktop. So I have all of the tables, columns, relationships, and calculations. And using direct query storage mode for those, it's able to query back to the core model. Now that I have this local model, I have options to personalize it. I could decide to rename things, but much more interesting would be, as is the case here, I can extend the model with new tables. So here I could go ahead and import data from a web page, perhaps from the US Census website, to bring in population. So there's a new import source group added to the model. My local model is now composite. I can create relationships across the two source groups. And then I can publish this back to the service, creating a whole new data set, which we refer to as a specialized model. Now, when my new report on sales per capita queries a specialized model, some of the data is local to that model because it's imported, but otherwise it uses direct query to the core model. Now, bearing in mind that it's an Azure Synapse Analytics source with direct query, well, then it does a direct query again across to the external data in Azure Synapse Analytics. So this is the new capability delivered in preview today, which is the ability to use direct query connections to Power BI datasets.
Now, you've just said that I can have a dataset that has a live connection to another dataset, and my mind is completely blown. So if I can have datasets that can connect to datasets, why couldn't I have that dataset that I'm connecting to connect to another dataset, connecting to another dataset, connecting to another dataset? Well, this whole concept is called chaining. This is where you have a dataset that has a direct query connection to another dataset. Now, obviously, this could get really confusing from a development and a maintenance point of view. So from a Microsoft point of view, we do not let you create chains of datasets beyond a length of 3. And also inside Power BI Desktop, when you're building your dataset, you have the option to discourage direct query connections, which means it'll stop people building direct query datasets on top of your core dataset.
Right. So what chaining means is this. You can chain up to 3. So these are direct dataset C uses direct query to query B, which uses direct query to query dataset A. Now, if report B is using dataset B, then dataset C is irrelevant. From the report's perspective, dataset B is local, and then upstream dataset A is remote. Now, if we looked at report C that does use dataset C, then the chaining would say it's local to report C and datasets A and B are remote. Now, just to point out that that property there in options allows you to discourage. I'm not sure, Chris, you might have some view on this. Why is it discourage when it really means prohibit? Discourage sort of sounds, we really don't want you to do it, but if you really do want to, then go for it. It's an interesting term.
I think it's because it really is discourage. It stops Power BI Desktop giving you the option, but if you were really determined, you would still be able to go away and do it by hacking the TMSL script.
Okay. So we could, if we were hackers, we could get around it. So this is telling
Absolutely.
Power BI to honor that property by not allowing a live connection to be converted to a direct query model. Got it. Awesome. Well, that covers off on model frameworks. Now, given that optimization was the top request, I think that we are compelled to work through optimization. So by the way, we will not get through all of these groupings tonight, but the good news is that the presentation in PDF is available for you to download to pick up the definitions that we missed.
Cool. So let's talk about some features inside Power BI that allow you to kind of do optimization. So first of all, let's talk about partitions. We've talked about tabular models consisting of tables, and a table stores data if you're in import mode. Now, a table can be broken up into multiple subsections called partitions. A table by default always has one partition, but if you know what you're doing, you can create a table with multiple partitions. Now, what's the point of doing this? A partition is the thing that can be refreshed. So if you create a table with multiple partitions, and each partition, for example, contains a different month of data, and only the most recent month of data changes, well, you can then, instead of having to refresh the entire table, you could just refresh just the partition in that table that contains the most recent amount of data.
So let's take a look at the tabular model object diagram. We've learned that those tables that are come from Power Query have a storage mode property. Okay, now what we're learning is that for import tables, there are one or possibly more partitions, and those partitions are helping you with manageability because now you can refresh at a much more granular level. Typically, these partitions are time-based, right? So partitions do not apply to direct query tables or calculated tables. So here, if you're working with Power BI Premium, you can use the XMLA read-write endpoint, and you can connect using Management Studio to your Power BI dataset. That allows you to use Object Explorer to explore the objects in it. Now, using Object Explorer, you can right-click a table, open up partitions, and this is just a very nice way to see or manage or even process individual partitions.
Absolutely. And if you've ever wondered how Power BI incremental refresh works, it automatically generates partitions. But as we said, if you know what you're doing, you can manually create partitions yourself. And what we've got here is a view of the M code for a manually created partition that I built. What we've got is a table called Internet Sales. It's got 3 partitions in, and the highlighted section of the M code here shows that this table, this partition, contains only the data where the order date is in the year 2021.
So what an awesome optimization, right? So we can control what we process. No need to process all data for a table. We can process individual partitions. Now, it gets more awesome because in April this year at the Business Applications Summit, Microsoft have announced a coming soon feature. So I don't think it's even in public preview yet, but it's being called the hybrid table, meaning now that those partitions can have different storage modes. So what that means is that that storage mode property shifts from the table to become a partition level property. And therefore, we could see that you could set up partitions, and here we can see time-based partitions, but it's storage mode as well. And what's interesting with this design is that your most recent time period uses direct query, guaranteeing you that you'll get all of the data that is currently residing in the source system. So it's delivering practically a real-time result. And yet history sits in import, and therefore, because we know it won't change because it's history, you'll get that fast analytic query over the top of it, but you'll get the added benefit of up-to-date data with the most recent partition being direct query. So this is something to look forward to, breaking down the barriers of, import model being fantastic and optimal, but suffering latency. You could consider a hybrid design like this.
So we've talked already about import mode and direct query mode, and these are the 2 fundamental ways that a table can store data. We didn't mention dual mode, and dual mode is important because it allows you to have a table that is both import mode and direct query. And depending on what happens in your query, Power BI can choose to either use it as an import mode table or to create a direct query.
So let's take a look at that model that we looked at earlier, and you'll notice in the model diagram something is slightly different. And it's the fact that 3 of the direct query tables with that blue bar are now a dashed blue bar or a striped blue bar, indicating that they are dual storage mode. So in fact, hovering the cursor over the account table, we see that it is dual. Therefore, it is both import and direct query at the same time. Now, let's consider how Power BI can query this model. All right, so first of all, just to be clear, nothing has changed. Still 2 source groups, still composite, still mixed mode, still a single data source. All right, so consider that we have just a slicer on the page, and all it's showing is the fiscal hierarchy from the date table. Well, this is a good example where Power BI would just use the date table, but it would use the import store for it. Okay, it'd be the fastest way to render that visual. Let's consider a different visual on the page. This time, what are the current fiscal year expenses? Now, current fiscal year expenses means that the data that it wants comes from the date table and the journal table. All right, so because the journal table is an account as well, because it needs to relate these tables together to query them, it will use the import store for date and account, thereby satisfying this entire query result from the import store. Okay, so Power BI will always, where possible, use the import store because direct query has the penalty of slower performance. Now, the next visual wants to look at forecast expenses. So in this case, it needs to bring in date, scenario amount, and account. Okay, now given that the scenario amount table is a direct query table, it will need to produce it'll need to use direct query storage for the dimension tables as well. And so in a simplistic way, if I was to translate what it does into T-SQL, it would be something like this. It would join those dimension tables together. It would use a where clause to filter by the year and the scenario, and it would group by account and give you the sum of sales amount. So that's essentially what it does in direct query mode. But interesting, what would happen when the visual says I want both actual and forecast at the same time, in which case it has to query all of the tables. So what Power BI will do is use both source groups, and then internally it will merge the results together. The formula engine will bring in the import data and the direct query data to provide that result back to the visual. All right, so the takeaway is with dual storage mode is you're giving Power BI the ability to find the most efficient query plan, which would be import if it could achieve it.
Okay, let's talk about aggregations now. Aggregations are a really, really important optimization when you're dealing with large amounts of data in direct query mode. One of the problems that you might find in direct query mode is that you're working with a very large amount of data. You run a query and you have billions and billions of rows in the source, but all you want is a very highly aggregated result. Now, in direct query mode, you run a report, Power BI generates perhaps a SQL query against the data source, and that data source has to go away and aggregate millions or billions of rows of data to get the result that you need, which can be slow. So if it's slow to do that when your report runs, well, what's the trick to improve performance? Well, you could pre-aggregate the data. This is an old trick in BI, creating aggregation tables. Now, here what we've got is an example of a Power BI dataset, and we've got a fact table called Internet Sales. We've got a date dimension table in dual mode. We've got a product dimension table. Now, if I was running a query against this and I wanted to get data from data broken down perhaps by year and product, I'd have no choice but to go to the Internet Sales table to get that data. But like I said, that could be slow. So what Power BI allows me to do is to declare some tables as aggregation tables. These are aggregation tables that are not visible to the end user, and they're not something that you as a developer actually need to worry about when you use or when you don't. But what you can do is you can say, well, here's an aggregation table. It contains data pre-aggregated to the date granularity. And what this means is that in some cases, the Power BI engine will be intelligent enough to know that certain queries can be answered from this pre-aggregated table. And when it does answer those queries from this pre-aggregated table, those queries will be much, much faster. So let's see some examples of queries that could be answered or not answered from this aggregation table. What we've got here is a visual that gets me my current financial year sales by product color. So this needs data from the product dimension and the date dimension. So that is going to have to go against the Internet Sales fact table. But it's not.
So aggregation is not used in this scenario,
yes.
Correct? And
exactly. But here, what I've got is I've said, give me my current financial year sales broken down by month. This does not need any product information. And as a result, it can be aggregated up from the pre-aggregated data that's stored in that Internet Sales aggregation table.
Awesome. And so aggregations are accelerators across your data. Now, the interesting thing is that aggregation tables can only be configured for direct query tables, right? But the interesting thing is the aggregation itself could be import storage or direct query storage. And if you used a direct query storage aggregation, it implies that you've got an optimized set. Like in Azure Synapse, you might have a materialized view that has that pre-aggregated data. All right, so an aggregation table itself could be import or direct query. Now, another announcement that was made at the Business Applications Summit back in April was another coming soon feature that is known as automatic aggregation. So while you can be explicit in their design, as Chris has just done in that model, you can just turn on a switch, providing that your data set's in a premium workspace, whereby with a slider control determining, what degree of aggregation you want, Power BI can determine based on usage what aggregations would improve performance and manage them dynamically for you.
And just to say that feature is now in public preview. It's no longer coming soon.
Oh, okay, awesome. to complete the topic of optimization, there is one more topic, query caching. So again, related to Premium, is that you can enable query caching, which means that query results, those analytic queries, their results can be stored and reused multiple times. So it's very common that the same query is evaluated and executed time and time again. So Power BI can detect this and reuse the results. That's query caching. All right, Chris, I don't have the clock in front of me, but based on the available time we have, where might we go next, having done the first row?
Well, we are at 12:30, so I think we are exactly on the hour mark from when we started.
Awesome. Well, then we can go straight to the conclusion, hey?
Yes, and there are a lot of questions, so I think we will need to spend some time answering all the questions that have come in.
Okay, well, let's wrap up with the conclusion, and then we'll just open up for questions and answer those for as long as we need to. So this presentation was based on a video recording. Now, in a moment, we'll share a link with you, and you can download this presentation, in which case the register here link is available, and you will see a more complete presentation done in warp speed, I think, Chris, wasn't it? We went through 50 within about 50 minutes. So for the topics that we have missed, we encourage you to watch the on-demand webinar. Now, when it comes for more details, this was just a glossary of terms. It was just introducing high-level concepts, but obviously there's much more research that you might want to do. And probably the best place to do that research is Microsoft's Power BI documentation, and more specifically, the guidance documentation. So just as an example, what I'm going to do is just pick up a link that says, you know, we talked about star schema. And so what I'll do is just open up a docs page for star schema. So I'm going to return here, paste in a link. And if I want to know more about star schema, what you'll find is that in the guidance docs, and I'm pointing where the guidance docs is, for a beginner that would like to learn what star schema is, what does it mean for Power BI models, and all of these related topics are covered in good detail with examples. So here's just one example of an article that might help you become a better data modeler. Now, there is a second one. We talked about import modeling, and this was an article that I wrote for Microsoft. I think it was my very first, and that was data reduction techniques, that import modeling is a very strong framework to use. And we only really want to switch to direct query on an absolute needs basis. So here's an article that provides you up to 8 different techniques that can help you minimize the amount of data to import so that you don't run out of, you don't hit that limit, that 1 GB limit or the premium limits as well. So do check out guidance documentation. A quick marketing plug. My company, Bitwise Solutions, has a comprehensive range of Power BI training courses. I do a lot of that virtually these days, as is the necessity. But if you're ever looking for online training, do check out my website. But otherwise, we can end up on this slide, which allows you using the QR code, or I will paste in a tiny URL, allowing you to download the PDF of the presentation, which completes, covers all of the terms that we would have covered should we had 3 hours in today's presentation. So leaving on this slide, Chris, I guess it's now a matter of just working through any open questions.
Yeah, absolutely. Prathi, James, do you want us just to go back up to the top of the list of questions and work our way down?
Yeah, we can do, or I have summarized them on a single slide if that would make life easier for you.
That would make things a lot easier.
Give me 10 seconds and I will share my screen. Bear with me. Here we go. Hopefully you can see that, and that should be the summary of, hopefully I've captured everything. I've tried to go along and get them as we've been going. So this goes back almost to the beginning, so some may have been answered as you've been going.
How did you do that, James? Are they just screenshots?
They're just screenshots. Everybody asks. It's nothing technologically clever, but it's quite a nice way of grabbing them all.
Okay, so let's start from the top left and work our way down each column. It used to be the case that with direct query mode, not all DAX functions are supported. Nowadays, I think we do actually support all DAX functions, but I remember somebody answered this in the chat to say that even if you do use certain DAX functions, you can end up with pretty bad performance, and sometimes indeed you can end up with some errors as well, where there are cases that the Power BI engine can't actually translate what you're trying to do back to whatever the query language used by the source is. So effectively, there are some DAX functions that you shouldn't use in direct query mode.
Right. So the answer is, so the question was, direct query mode, is it valid that not all DAX functions are supported? Okay, the answer is that pretty much all DAX functions will work, but the deal is this: if they don't translate to the native query language, then what Power BI is forced to do is bring in an intermediate data into Power BI and use the formula engine to transform it to what the query wants. And there's the performance hit that Chris is describing. So while it might work, you want to test thoroughly, especially under a workload of multiple users and large volumes of data, that it does work as you would expect and with sufficient responsiveness.
Okay.
So I'll take the next one because it's real time. Yeah. So it's like,
yes, depends.
So how would you get up-to-date data from a REST API to Power BI? Oh, so no, it's not the REST API for pushing data. Chris, this is you. It's Power Query.
Yes, because I've written a blog post and put that in the chat. This is a very common question. The answer is you would refresh your import mode dataset frequently. In theory, you could build a custom connector that supports direct query mode, but your REST API would have to be really quite rich and probably have a query language on top of it. So effectively, you just need to use import mode and refresh frequently.
Okay, next one from Sue is the new dataset chaining for Premium or Pro. It's for everybody. No restriction on chaining by license. Stephen then asks, do all chain datasets need to be within the same workspace? No, because remember, one of our opening definitions was that data sets, while they do belong to a workspace, so long as they're within the same tenant and the permissions are in place, you need build permission of the data set to do this, then you can chain within the tenant, no restriction by workspace.
Mm-hmm. Can a partition be selected? No, an end user does not see a partition. They see tables, but they will never see a partition. A partition is something that is managed internally by the Power BI engine. How do you define partitions? Incremental refresh does generate partitions behind the scenes. If you have premium or premium per user, you could also use tools like Tabular Editor to define partitions as well.
Okay, so Paul then asks that he has a model with an import-only data source. When the model is published to the service, it appears as a report and a data set. Is this normal? Absolutely. So remember, Power BI Desktop is two different authoring tools in the one product. So you've got modeling, and that results in a data set, and you've got the report that results in a report artifact. Just to an aside there, Paul, there is a great guidance article that says what you're doing isn't necessarily a recommended practice. If you want to decouple them, it's actually a better approach. Build the data model, publish it, then open another Power BI desktop file, live connect to it, and keep the report in a separate file. It might become more manageable in time if you keep them separate. So 2 PBIX files, one for the data set, one for the report.
All right. Is there a way to access a PBI dataset from other tools like R? Yes, but only if you've got Power BI Premium or Premium per user, because this is where the XMLA endpoint comes in. Power BI datasets can always be accessed from Excel, for example, but I believe there is an R library that you could use to get data through an XMLA endpoint. You would still need to write a query to get that. Can you, and yes, you can run R code within Power Query in Power BI, which I don't think is quite the same thing. Yes, XMLA endpoints. Can third-party tools be used to access and report? Yes, that is XMLA endpoints again. Datasets and deployment pipelines. So when creating a pipeline with an imported dataset, the dataset is not pushed correctly to test. Works fine with data it's pushed and refreshed via a gateway. Any thoughts about why this is happening? It depends on what you mean by not working properly, but if you have found a bug it is always worth opening a support case to try to get that bug fixed.
Okay, and I think that brings us to the last one I can see is Afifa has asked, how does paginated reports get up-to-date data from a Power BI dataset that is connected to an ERP through a PQ connector? So paginated reports get up-to-date data from Power BI dataset. We'd want to know, is it using import or direct query mode? Is that Power BI dataset in import or direct query mode, not knowing what your ERP system is? But let's put it this way, paginated report is just another, is when it uses a Power BI dataset as its source, it's just querying the model, probably using DAX or MDX. So if the dataset that it's querying is direct query, well then paginated report would be delivering up-to-date data. So the answer is, what connectivity mode is the ERP system being used, or is Power Query using to connect to it? It's possible that it could be real time. Be careful there. Paginated reports have a 10-minute caching, by the way. So even you'd have to do a force refresh to make sure that it discarded the per user cache of the report. But the other thing that's cool about paginated reports, there is this property called auto refresh, so that you can have a paginated report auto refresh on a number of seconds that you can configure. So that's just an interesting side point about real time and paginated.
And there was another question in the chat about XMLA endpoints. And I haven't followed that link that Matt W posted, but if it's the one from Guy in a Cube, that is a good place to start. Very quickly, XMLA endpoints. So the Power BI uses basically the same engine as Azure Analysis Services or SQL Server Analysis Services Tabular. And in the days of analysis services, you had a kind of a database engine that you could query, but lots of different front-end tools could connect to it, and they connected to it using a protocol called XMLA. The XMLA endpoint in Power BI just allows you to connect to a Power BI dataset in the way that tools in the past were able to connect to Azure Analysis Services or SQL Server Analysis Services. And there are lots and lots of third-party tools out there that can connect to analysis services. And if a tool like Tableau can connect to analysis services, it can also connect to Power BI through the XMLA endpoint. So just to summarize, yes, you can use tools like Tableau to connect to your Power BI dataset. Not that you would want to, of course. Cool. All right, I think we're done.
Brilliant.
I think we are.
Thank you both ever so much for a fantastic and energetic session, as always. I'm on the web version of Teams, so apparently I can't turn my camera back on while I'm still screen sharing. But as always, we would love your feedback. I'll paste a link into the chat as well, so you've got something to click on. But we'd be very grateful for feedback on the session and mine and Prafi's disorganized introduction at the start as well. If you can kind of forget that bit and focus on the session, that would be lovely. And as we've mentioned, we'll be posting the recording up on our YouTube site, probably be in about a week's time, as we're away over the next couple of days at Power BI Next Step in Denmark, which I think we're all very excited about for the first in-person conference that a lot of us have been to for a very long time. So I think that's everything from me. Watch out for announcements on the next session. We'll be posting those up on our social media sites on LinkedIn and Twitter, and obviously the event itself will be hosted via the Meetup site, so you'll get the notification through there. Thank you very much again to Chris and Peter for the session, and thank you everybody for joining. I'm going to stop sharing so I can see you.
Thanks for having us. Well, good morning, good afternoon, or good evening from Melbourne.
Cool. Thanks a lot, everybody, then.
Thanks, guys.
Cheers.
Bye-bye.
Thank you. Bye.